Okay, so this video is going to take a look at those 3 practice problems that were assigned to you working through percent composition or mass percent composition. So they kind of built in complexity in terms of what was going on, but they all follow that same premise that you're finding the percent of each individual element based on how much mass of that element is made up within the compound. So if you followed the video, the first thing that you should have done with all of these is determine their molar mass. So starting out with magnesium fluoride, we know that it's made out of 1 magnesium and 2 fluorine. And I'm going to have to apologize ahead of time. My one bunny, Shaylee, is in here with me. And so if you hear any sounds in the background, it's just her investigating. She just got put away for the night. So we have magnesium is 24.31 and fluorine is 19. Multiplying and adding them up, the grand total molar mass is 62.31 grams per mole. I'm going to go ahead and just fly through molar mass on all 3 problems. So in the next one, you should have listed out that calcium, there was 1. You have to remember in the next one, you're distributing into each. So we have oxygen with 2 and hydrogen with 2. Hydrogen's 1, oxygen is 16, and calcium on your periodic table is 40.08. So for its molar mass, once you multiply and add it up, it's 74.08 grams per mole. And the very last one is this ammonium phosphate. So again, you have to right off the bat do some distribution. So we have nitrogen, and there's going to be 3 of those. Hydrogen, again, you're multiplying. So there are 12 hydrogen. Phosphorus, there's 1, and oxygen is going to be 4. Individual masses, nitrogen's 14.01. Hydrogen, we use the 1. Phosphorus is 30.97. And oxygen 16. So we multiply and add those up, we get an even total of 149 grams per mole. Now in each problem, we're going to set up to solve for the percentages of each of these individual elements. So the first one, I'm going to go ahead and start finding percent magnesium. So again, it's the mass of the magnesium, so there's 1 times the 24.31 gram per mole, all over the total molar mass of 62.31. The last step was multiplying by 100%. And again, you do not put that percentage sign into your calculator. It's a unit. 39.01% of this is magnesium. So the remaining half of this problem is that I'm going to go ahead and set this up to solve for fluorine. So my percent F. So that's going to be the other half of my molar mass. So that 2 times that 19 gram per mole over that same molar mass of 62.31 times 100%. When we go ahead and total that all up, we get 60.99% fluorine. Again, the way to check your work is to make sure that your percentages add up to 100. So going on to this next problem here with the calcium hydroxide, you could start out with finding your percent calcium. We have 1 of them. Molar mass for it is 40.08. Molar mass of the compound was 74.08. Again, we're going to multiply by 100%. And so for the total there, you should have got 54.31% calcium. The next part of the compound you could solve for is the oxygen. So we have 2 of them times the 16, all over the molar mass of 74.08 times 100%. You can go ahead and multiply, divide it out, and for the, the oxygen, I got percentage of 43.20 with rounding, and that's percent oxygen. So you had one last element within this compound, and that is the hydrogen. You should see, and you can kind of make the assumption based on its molar mass of the hydrogen compared to the other two, that it's going to be relatively low in percentage. So when I solved this one, I got 2.70% of it is hydrogen. All right, so the very last one, you had your ammonium phosphate. So you have, again, your percentage for each of those. So percent N is the 3 times the 14.01. And that molar mass, again, was the 149. So when you multiply by 100%, after doing your multiplication and dividing it out, I got a percentage of the nitrogen as 28.21. So the next one you could have solved for could be the hydrogen. So hydrogen, there was 12 of them, times the 1 gram per mole, still over 149. And still multiplying by that 100. When you work that one all the way out, it's 8.05% hydrogen. Again, a real low molar mass, so again, it's usually not going to contribute to very much of the percent composition of it. Phosphorus is the next one on the list. So we had one of them at 30.97 gram a mole, and still over 149. Times that by 100%, and our percent phosphorus is going to be 20.79 phosphorus. So last but not least, we have our oxygen. So we have 4 of them, each of them have a mass of 16 over the 149 times the 100% equals 42.95% oxygen. If you had some kind of mistake and you're not sure why you mixed up something, and I realize now as I'm looking at my screen what I see on the iPad is a little bit different than yours. I'm going to write this down below just so you can see it a little bit easier. So 42.95% was the answer for that, so you guys can see it. So if you have any questions, concerns, if something didn't work out quite right, please feel free to reach out to me.